Alright, so one thing we know is that when we see this, we know this is the moment equation, right? Yes, it's the same as the moment equation, right? But the question is, in fact, this is a fact that when we have other forms of this with the different y's, we know that there are different names for them too. So when we have this, ei y third derivative, right? This is where we have the shear force equation, right? Of this, right? And then when we have ei fourth derivative, this is where we have the load equation, right? And then we have this, which we've already said, first derivative. This is where we have the slope equation, which is theta, or we just see slope, right? Slope equation, right? And when we have just ei, which we've been saying repeatedly, y, just y, that's where we have the deflection, right? These are some of the things we should notice, and each and every one of them has their own symbols, right? The deflection, which you can just say theta, right? Or dy dx, right? The slope equation. And then deflection, you can just say y, right? These are their symbols that we use to represent them generally. Okay, yes. And then for this particular example here, we are going to just look at the boundary equations, but we'll solve it later, right? So let's discuss this. When we look at the point A, right, this very point here, what we can see about point A is that there's a support there. There's a cantilever, right? So there's a support there. So one thing we can see at point A is that, so let's see, at A, start from here. At A, and then it's very convenient that before you even start solving the problem, you're able to determine the boundary condition, because these are the conditions that help you get a constant, right? So at A, we can see that x is equal to 0, and then we know that at that point, at that very point, there is no sharing of that particular element there. So we can see that we have our v. So let's see. At that point, let's do this again. At that point, that's why we have our x to be equal to 0. One thing that we can see is that there will be no deflection at that point, right? No deflection. So we can see that at that point we have y to be equal to 0, right? And at that same point, let's see, at x, this one, so at x is equal to 0, you can also see that there is no slope, right? Yes. So we can also see that y derivative is 0. And then we come to this point. Let's see, at point B, let's do this. At point B, we are seeing this, we have determined this boundary condition even after we've applied the force and then there's been any bending or whatsoever, right? So in this case, if there's any bending in a, what's the name? In a cantilever, to be something of this sort, this your beam, right? And then if there's any, let's see, if there's the initial position of it, right? And this, if there's any bending, to be something of this sort, right? And here will be the support, right? The support. So see, even after bending, there will be no, what do you call it? There will be no deflection here, right? And there will be no slope here, right? So this is no deflection, there's no slope, right? And when we look at B, so at B, we can see clearly that that's where there will be the maximum deflection, right? So at that point, we have our x being L, right? And then we have our shear force being 0. Why? Because when we consider this point here, if we are able to divide this beam into very small, tiny, infinite elements, right? We get to see that very element at that point here, there will be no shear in it, right? And then we have let's see, that same where we have x is equal to L, right? This one, this another one here. Yeah. At that very point, we also have our m, right? Our moment being 0. Why? Because at this very end here, looking at how this, what do you call it, this force is applied, look at it very well. You see that this is where there's resistance, right? So the moment is basically the beam's resistance to apply stresses on it, right? So here is where the beam's resistance is very low. So you see this is the moment, right? This is the moment, bending moment diagram, right? So you see this is where the moment is maximum. This is where it's least. So it comes here, it becomes almost zero here, right? So that's where we have our moment at that point B. We have it to be zero, right? So these are the boundary equations. So at A, this is what we have 2, and at B, this is what we have 2, right? All right.